All right, and halogens is sort of the opposite. It wants to gain an electron, and so the reactivity increases on your way up because there is less electron shielding, and there is less distance from the nucleus to the valence shell, the outer one. So again, just for emphasis, just like electronegativity, the reactivity increases up the group as the electron is easier to gain. So this one has a greater effect at pulling in an electron to get a full shell, whereas there's a more electron shielding and it wants to pull it to a further distance further away, so it's not as attractive. Doesn't have as much electrostatic attraction. That being the case, also, why does it go from a solid to a liquid to a gas? That's going to have to come up with intermolecular forces. There's more electrons, so there's more London dispersion forces. So just hold that thought until you get to that topic. And so these are just diagrammatic pictures. That's a liquid. It looks a bit like a gas though. And that's a solid. There'll be some solid iodine there. They're gases and they get darker in color as well. And so how would you write the reactions? Chlorine is chlorine and bromine, if you just go back to the periodic table here. So chlorine will be a greater ability to gain electrons than bromine. And so if you look down here, so chlorine will be the one that will gain electrons. If I did it in this direction, I'd write no reaction. Because chlorine has the greater ability to gain electrons, it'll rip off these extra electrons here, take it for itself, and bromine will be the one that basically only has electrons in unfull shells. Still sharing though to have a full shell, just like this is sharing to have a full shell, but this one's more reactive, so this one is the one that has the ability to get a full shell by stealing an electron.